All right, so you have in your table of contents, page 21. I've started. 21 and 22 will be simplifying radicals. So, we will go to page 21. And at the top, label it simplifying radicals. And we're just filling out our examples on the pages today. Don't have anything fancy. Alright. So, if I gave you a square root that you already know, then it's easy to simplify. So if I said the square root of 121, you would say it is what times what is 121? 11. Good. Now, there are actually two answers here. It's 11 and 11 times 11 is positive 121. But negative 11 times negative 11 is also positive 121. For the sake of where we are and what we're doing, you only have to give me the positive solution, but understand that there is that negative solution as well for a square root. Okay? If the index here is not written, then we assume it's a 2. And so that means there are 2 identical factors that will get you 11. Are you with me? Okay. We can put variables in there. So I'm going to do the square root of 144 n to the 6th. And so we can think of these separately. So in your mind or on paper, we can separate 144 and the square root of n to the 6th. And what is the square root of 144? Good. And remember that your index here is a 2. So what we're saying is, if we had 6 n's, how many groups of 2 could you make out of that? 3. So the square root of n to the 6th is n cubed. And that should make sense to you because, using our power rules, what is n cubed times n cubed? N to the 6th. Good, because you're supposed to add your exponents, right? Okay. So your answer would be 12n cubed. That's simplifying it. Yep. What simplifying means is you are taking out of the radical all the square roots. Okay? And so if they're even like this, 121 is a perfect square. So it has a square root 11. And 144, square root of that is 12. And we can even break up the n to the 6th into 2 equal groups. Okay? 2 identical factors. That's what you're looking for. If it's a cubed root, that means that the index is a 3. And so we're looking for 3 identical factors. So the index tells you how many identical factors you have to have. So, what is the cubed root of 27?
3.
Good. And can you take 9 n's and divide them into groups of 3? And how many would be in each? Very good. And so that would be your answer right there. Good work. Good job. Everybody okay so far? All right, so I'm going to give you one to try. we'll do the cubed root of 125, a to the 12th, b to the 6th, c to the 15th. It's not more difficult, it's just longer. So if it helps, you can separate them. Then you have to do the cubed root of a to the 12th, cubed root of b to the 6th, and the cubed root of c to the 15th. So cubed root means that 3 identical numbers multiplied to be 125. 5 it is. You have 12 A's being multiplied. Groups of 3. Very good. There are 4 of them. Then we move on to B. If you have 6 B's and you need 3 identical factors, how many groups do you get? Excellent. And then we have 15 C's being grouped into 3's. There are 5 groups. Very good. Divide the exponents, yeah, by the index. So exponent divided by the index, the next exponent divided by the index. The only thing you do not divide, though, the coefficient. You actually have to know what the cube root is. Okay? And we expect that you already know, like, most of them, so we'll give you, we'll keep the numbers lower so that you can just know them. And you might have to do trial and error. If you're thinking it might be 9, then take 9 times 9, which is 81, times 9 again, and see if that's your answer. Okay? Trial and error. It's just a one homework sheet. It's not a real thing. Okay. Next. All of these have worked out evenly because each of these actually had a square root or a cube root. So I was choosing my numbers very carefully. But that isn't always the case. We know that not everything works out perfectly. So we're going to use like a factor tree to simplify these. Okay? So the calculator is going to give you an answer in decimal form. That's not acceptable, because it's going to round. Your answer will have radicals in it still. Okay, so the calculator at this point is not helpful to you. So let's say for number 5, I'm going to leave variables out right now. Let's just work on it. Let's do the square root of 120. Now, we know it's going to be close to what number? 5. The square root of 120? Yeah, plus 5. 11. Oh, square root. This is really close to 121. And the square root of 121 is 11. So, but it does not have a perfect square root. So what we do is we start factoring, like a factor tree. So I want you to draw that. And you can give me any 2 factors of 120. 12 and 10. Jack, any 2 factors of 12. Excellent. Now, when you get down to a prime factor, I want you to circle it, because the larger the original number, the crazier your factor tree. And our eyes are going to lose some of these, and you're going to leave out a 2, and you don't mean to, bless you, but you just didn't see it. So we're going to factor every prime number that we get to. All right, so then 6 has to go Good. And you circle both of those. In the end, we ignore any of these that aren't circled because we used the 12 when we broke it into 6 and 2. And we used 6 when we broke it into 2 and 3. So the 6 and the 12 technically aren't available to us anymore. Okay? What is 2 times 3 times 2? 12. So do you see how we actually used the 12 down here? So that's not available to you. What are the only factors of 10? Good. Okay, circle both of those because they're prime. Now, in order to simplify a radical, you look at your index. What is my index here? 2. 2. So in order to come out of the radical, you have to have 2 identical factors. So looking at your circled prime factors, what do you have a pair of? 2. You have a pair of 2's, right? So, this one, what's the square root of 2 times the square root of 2? 2. Very good. Okay, now if you're like, how did he get that? The square root of 2 times the square root of 2 is the square root of 4, which is 2. So every time you have a pair of factors, they get to come out of the radical. It's like the buddy system. They can go outside to play if they have a buddy. If they don't have a buddy, it's not safe to go outside and you have to stay inside underneath the house. Okay? Yes, this is your house. All right. Now, do you have any more pairs? No. So, everything that's left over has to go in-house, or under your radical. So what is 3 times 5 times 2? Good. So your simplified answer is 2 square root 30. Now the calculator would give you some decimal here, okay? Here's what I want you to do. If you have a calculator, take it out. Yes, Luke?
Wait, so when you did like the 2 to the square ratio, is it only with 2? Or is it like if you have like
If there were 2 3s, I would let a 3 come out as well.
Okay.
So you'd have a 6 then, because 2 times 3. So every pair of numbers gets to come out.
So yeah, what if it's like 2 2s, 3 3s, like how would you
So you bring out the 2s, you bring out the 3, and so you say you have 6 out there. Because everything's multiplication. Okay?
10.95.
Okay. Here's what I want you to do if you have a calculator. Take the square root of 120.
10.95. 4451.
Okay. Now, is everybody cool with that? I want you to take the square root of 30 and then say times 2. That's right. That's right. You get the exact same answer because they have the same value. You're not changing the value. What you're doing in math, you know how you can't leave a fraction 4 over 6 that's not reduced? You can't leave square roots underneath a radical. There's a square root in 120. It happens to be 4. Okay, 4 times 30 is 120, right? Well, the square root of 4 is actually 2. You have to undo the squares. So, to simplify a radical, you're taking out the perfect squares. And so, that makes it simplified. 30, the factors of 30 are 3, that doesn't have a square root, 5, that doesn't have a square root, and 2, that doesn't have a square root. That's why they have to go underneath. Are you with me? Okay. Let's do another one. It's okay if you're lost now. The more we do, the better we'll get. It's not simplified. You would never leave a fraction 4 6. Because in math, that's not simplified. It's not taken down to its prime. Same thing here. It's just not acceptable. It's not okay. All right, yes?
So like, you saw the same one last year, like the big card on one side and the small card on that side. So what's the dog with that thing?
for square root?
Yeah. Big part on the inside of the garage, small part on the outside of the garage.
Well, just so you know, this number might be bigger sometimes than this one. I don't know what he's talking about. I'm sure that whatever he was talking about, that's true. But in these cases, your outside number might be bigger than your coefficient might be larger than your radicand. Look at me and my mathy words. All right, let's do the cubed root of 500. Now, because this here was, the index was a 2, I was looking for groups of 2 to come out of the radical. If your index is a 3, then you have to have groups of 3 before you're allowed out of the radical. Okay? Are you with me? All right, so let's start factoring 500. Give me 2 factors of 500. You start. Okay. Now, when you write this, it's the cubed root of 250 and the cubed root of 2. And then that gets 2 is prime, so you circle it. If you started with a square root, then everything in your factor tree must have a square root. But if you started with a cubed root, then all your factors in the tree have to have a cubed root. Okay? All right, let's keep working on 250. 25 and 10. Good. How about 10? Awesome. And then 25. Good. Okay. Notice, yes, no matter what factors you use up here, you'll end up with the same answer. So you could have used 25 and 10, 25 and 20, 50 and 10. No matter what, you'll end up with the same answer in the end.
Do we have to have like the radical?
Yes. You have to. And it has to match. So see how this is a square root and all of these are square roots? Okay. So this is a cubed root, so they all have to have cubed roots on them. Good question. Have to have that. So we have to have, technically, for those who still need a visualization, I could rewrite this. I could say that the cubed root of 500 is really the cubed root of 5 times 5 times 5 times 2 times 2. Okay? And how many do you have to have before they're allowed to come out? 3. So these 3 get to come out of that radical. Because what you're saying is 5 cubed is in that 500. There is a cubed root, or there is a cube in 500. Okay, the cubed root in 500 is 5. But we have leftovers. Because the index says you need a group of 3, there are only 2 2's here. That's not safe enough for them to come out. So they have to go underneath the cubed root. And 2 times 2 is 4. Notice that the problem gave me a cubed root. So in my answer, I have a cubed root. Okay? So just like somebody taught you to simplify or reduce fractions a long time ago, this is simplifying or reducing radicals. Go ahead.
Was that the answer?
Yeah? No, this is your answer. Yes.
If it was like the square root, would you make that 4 to something like that?
Okay, what?
Is that 3 or 3?
Okay, so then you would have a pair of 5s out, a pair of 2's out, so really you have 10, and then this little guy has to go inside by himself. Yep. To check this, how many did you need? 3. So you would have to do 5 times 5 times 5, which is
125.
125, and then multiply it by the 2. not you, multiply by the 4, sorry. 5 times 5 times 5. You knew you had 3 of these, because that's the only way you're allowed to get out. So 5 times 5 times 5 is 125. And then there's still a 4 left over. So you multiply that by 4. And you get 500. Yes?
Wait, so how do you get to 500?
This tells you how many you have to come out. And there were 3. You're like, do I have 3 of anything? Yeah, I have 3 of these 5s. That's why the 5 gets to come out.
5 to the third power.
Inside here, yes.
Yeah.
But this is just 5.
But it looks like 5 to the third power.
Oh, it does. But that's not what it's supposed to look like.
So there's like 4 or 5, and then
And 3 get to come out.
And I want to
1 has to stay inside.
no matter what.
No matter what, this tells you how many you're allowed to take out. You can't take out less, and you can't take out more. Yeah.
What if
You can't take out like all, like any of them, you just
Yes. It'll end up back like this. And you're like, oh, well, it can't be simplified. Yeah.
What if all you like it takes out everything?
Then you won't have any radicals like this. Yeah, you'll just have like one number outside. Now, of course, we may have variables in there. So, let's do number 7. Sure. The cubed root of 64 n to the 4th m to the 6th. Write it down, folks. Now, we're going to take the coefficient 64, and we're just going to work on that, and then we'll talk about our variables in a second when we're done. I'm not walking away going to my computer.
8 times 8.
Okay. So, I'm going to wait until we're all done, because this isn't coming easily to you, so you don't have the opportunity just to talk through me. Thank you. Now, we're going to break this up into 2 factors, and because the original problem had cubed root here, our factors have to have cubed roots over them. What do you want to break this into? Okay. So then each 8 can be broken into 4 and 2. Circle your 2. And each 4 then can be broken into 2s. Bless you.
You didn't have to do this.
Okay. Didn't have to, but you're assuming everybody has these memorized. Your friends do not.
Well, I didn't have it memorized. I just realized that.
All right, let me walk through this. Okay. Okay, now, I'm looking for groups of what? Groups of 3s. Excellent. So, I'm going to use 1, 2, 3. So, a 2 gets to come out because I had a group of 2s. And then, it just so happens that I have another group of 3. And it's 2 again. And I'm out of factors. So there won't be any leftover numbers underneath the radical, because we don't have any leftovers. Are you with me? Okay. Now I have to work on the variables. So, let's go to n. This is saying that you have, underneath this, 1, 2, 3, 4, right? If I have a group of 3 right here, that means an n gets to come out. But how many are left over? 1. So I do have to draw the cubed root there and let that n go inside. Why did I leave space outside. Good, I still have that M to take care of. So I had a group of 3 N's. So the N got to come out, and there was one left over, and he has to go inside. Now, we're moving on to the M's. You have 6 M's, 2 pairs. Are there any remainders? No. So do I have to have any M's in my radical? No. Now that's kind of a messy answer, so we're going to clean that up. What is 2 times 2?
4.
And then you have N, M squared, cubed root, N. Has everybody finished that problem?
Yeah.
You all have that written down? Almost.
I know how to do it, though.
All right. 8. We're going to do,
Is this the last one on these 2 pages?
for today.
Okay, because I know you want to page it, and I don't want to get them.
7 times the square root of 90 x to the 5th y to the 7th. Now, we have not had a coefficient on the outside before. So you keep it there, but in my experience, 12 years, there is always a group of kiddos who start here right away, simplify it, and then just give me that answer. They completely forget to go back up there and multiply times that 7. So the first thing that I do is I'm going to bring down that 7, and I'm going to write it as part of my answer. And then that way I don't forget it. And we'll deal with our variables in a second. Right now I want you to factor with me 90. It's the square root of what and the square root of what? Good. And what do you want to use for 45? Okay. And what about 9? Good. Remember, we're looking for a pair of something because the index is a 2. What do you have a pair of? Good. So the 3's get to go outside with that 7. Use them. And then who's left over? 5 and 2. But we can't forget about our variables. So, I have 5 x's and I need to group them into 2's. What's 5 divided by 2? Give me something, remainder, something.
2.
Good. 5 divided by 2 is 2, remainder, 1, right? 4, if you can't visualize it. 1, 2, 3, 4, 5. There's a group of 2, and there's a group of 2. So how many x's get to come out? 2. This little guy's left over. He has to go inside. Same thing with the y. How many groups of 2 can you get out of 7? 3. And then you have 1 remainder. And just in case, 1, 2, 3, 4, 5, 6, 7. Here's a group of 2. Here's a group of 2. There's a group of 2. So 3 y's get to come out, and then this little guy has to be a remainder. So to write it nicely, we have 21 x squared y cubed times the square root of 10xy. So,
Wait, so you wouldn't like put this like multiply the 7 inside the square root?
no, because 7 was outside, so it stays outside. Yes.
Will there ever be a time that 7 was in the square root?
But it would just be hidden in the 90. There was a 5 and a 9 and a 2 in the 90, and you didn't see it, so.
Are we gonna have to go from like where we are right now, like 21x to 1, and then,
On the rest of this time, we use salt, never use 15 reports and lobby this time, please. Salt, to just increase reports of the lobby this time for dismissal, thank you.
And there's a lot of it, so don't be angry. No, you have to do all of them, so just don't be angry.
All right,